The following video contains sample clips from the course Solving X and Y Inequalities. Greater than or equal to relationships.
Very good. Less than points to your left and greater than points to your right.
Because there are often very many solution pairs to the inequality statements.
Very nice. We use graphs to describe solutions to inequality statements.
To an equality symbol.
Very good. We use the graph of the equality to graph the inequality.
Shade above our line. And this shading represents all of the pairs of values. This emphasizes that our line, for all of the points on our line, the points directly below those points, every point in that shaded area is located by an X and Y coordinate.
Good job. If Y is all alone, then less than is always below the line. Nice work. It is usually easier if we change the form of the inequality to Y all alone.
To an equality symbol. To a broken line. To emphasize.
Good job. To graph the inequality statement, we first graph the related equality.
The related equation line describes points and ordered pairs that are solutions.
Nice work. The related equation line describes solutions to the inequality. Nicely done. When we have Y all alone and a less than or equal to statement, we shade below the related equation line.
If we are talking about Y is less than, or Y is less than or equal to in our inequality statement, we shade below the related equation line.
Nicely done. Greater than, above. Less than, below.
This calculator uses a drop-down menu, and you select the direction of the inequality from the menu. When we graph that inequality statement, we get the following graph. Then, on the same graph, we graph the second inequality statement. These two graphs together show us where the points are that are on both graphs. We shade above the related equation line y equals a negative x minus 2. We shade above the line because the inequality statement is in the form y all alone, and it is a greater than statement. Let's see what that effect is on the graph. Let's see what happens when we graph y greater than x plus 3 again. It graphs as before. But now, let's see what happens when we graph y less than a negative x minus 2. Now we see that our graphs intersect in this region of the graph. This area represents the ordered pairs.
Very good. The red shaded area represents y is greater than x plus 3 and y is less than negative x minus 2.
When we graph y less than x plus 3, we shade below the related equation line rather than above. And when we graph y greater than a negative x minus 2, we shade above the line as before. But our intersection area of the graphs is different.
Nice work. The area shaded in red represents the solutions to y is less than x plus 3 and y is less than negative x minus 2.
Except for one important boundary area. These points on the related equation line.
Very nice. Part of the boundary line y equals x plus 3 is included in the solution area of the graph. Nice job. The intersection area on the calculator is y is greater than x plus 3 and y is greater than negative x minus 2.
Solving x and y inequalities.